In this video, we're going to revisit the idea of system of linear equations. Because if we want to solve a system of nonlinear equations, then we will be using the methods in solving system of linear equations. So knowledge about solving system of linear equations is crucial and in fact very important. Now, what is a system of linear equations? So it is a set of equations that describe something, that describes some phenomena. Okay, so for example, if you are a manufacturer, you manufacture products, you want to know which product you will produce more than the others to maximize profit. Okay, and typically solving these kinds of problems involves solving a system of linear and nonlinear equations. Okay, now when we talk about system of linear equations, the simplest and the easiest example is a system of two equations. Okay, so it's a system of two equations describing something. Now there are three possibilities on how the graph will look like. So let's do that. So let's have a graph right here. So now, so your graph could look like this and this, where you have an intersection. Okay, you have an intersection. Your graph could look like, I don't know, like this, say that and then that. So these are parallel lines, and in this case there's no intersection. Okay, we could also have a case where this is your graph. So the first graph is something like that, and the other graph also is that exact line. So you have two equations with the same graph. Okay, so in this case you have infinitely many intersections because basically all points are intersections of these two lines. Okay, so these are three possible scenarios for a system of linear equations. Okay, now what does solving mean? Okay, what does it mean when we say we solve a linear equation? Graphically, solving a system of linear equation means finding the intersection. Okay, so this means that this one is the solution to this system of equations. That intersection is the solution. Sometimes a system doesn't have a solution. In this case, this one doesn't have a solution because these are parallel lines. Okay, there are no intersections anywhere. Okay, so in that case there are no solutions. Now there are also cases where the system has infinitely many solutions. So in the case of this one right here, where your two graphs overlap each other, then as I've said earlier, all these points are basically intersections, and so you have infinitely many solutions for that one. Okay, let's have an example and then let's solve it using the three methods of solving a system of equations. First one is the method of graphing. Okay, let's do that. For example, let's say our system is x plus y equals 0 and 2x minus 3y equals 5. Okay, let's solve this equation by graphing. Okay, let's graph our first equation. Our first equation is x plus y equals 0. So to graph a linear equation, basically you just need 2 points to connect. Okay, so to find the first point, just set x to 0 and solve for y. So if x is 0, that will give us 0 plus y equals 0, and that gives us y equals 0. So the first point is 0, 0. Okay, now the second point would be to equate y equals 0, but we cannot do that since we already have y equals 0, so we need another point. Let's try y equals 1. Okay, so let's say y equals 1, and then let's solve for x. Okay, so if that's y, then x plus 1 basically x plus 1 equals 0, and then solving for x, we got x equals -1. So the second point would be -1, 1. So where's negative 1? 1, negative 1, and 1. So that's there. And then just connect these 2 points. I think. So that should be the line. Okay? That should be the line. It's not a perfect straight line, but that, you get the point. Okay? Now it's time to solve for the second, it's time to graph the second equation. So you have 2x minus 3y equals 5. So same process. So set y equals 0 and then solve for x. So that will give you 2x minus 0 basically. So that's minus 3 times 0 equals 5. So that's 2x equals 5. X equals 5 over 2. That's equivalent to 2.5, 2.5. Okay. So our first point is 2.5 comma 0. So where's 2.5 comma 0? So that's here. Okay. The second point will be, so let's set x equals 0 and then solve for y. Okay. So if that's 0, so that's 2 times 0 minus 3y equals 5. This will give us this will give us y equals 5 over 3. No, negative 5 over 3. Okay, so negative 5 over 3 is, negative 5 over 3 is negative 1.667. So where's that? So that's 0, negative 5 over 3. So let's see where that point is. So 0. So that's about here. Okay. That's there. And then all we need to do is connect the dots. So we can just connect these 2 points. Let's do that. So that's okay. And then we can extend if we want to. So that's the graph of this system. And so to solve or to find the solutions, all we need to do is find the intersection. The intersection is this point, and that point is at 1 comma negative 1. 1 negative 1. So our solution based on the method of graphing is 1 comma negative 1. Okay, so that's our solution. Now the second method is the method of substitution. Okay, so the idea of substitution is we will solve the variable, we will solve one of the variables in terms of the other and then plug that value to the second equation. Okay, so let's work on this one right here because this is a bit simpler compared to the second one. So let's solve for maybe x or y. It depends on you. So let's solve y. So y equals negative x. Okay, and then I will plug this value to my second equation. So where y is, I will replace that with negative x. Okay, so I will now have 2x minus 3 times y, which has become negative x, equals 5, and then solve for x. Okay, so let's solve for x. So this is 2x plus 3x equals 5. This is 5x equals 5, and then x equals 1. So that's my x value. And then to solve for y, all we need to do is substitute this value to any of our equations. So I will do that here because this is already solved for y. So that will give me y equals negative x. X is 1, so that will give me negative 1. So my y value is negative 1, and so therefore my solution would be 1 comma negative 1, which is what we got when we use the method of graphing. Now we will use the method of elimination. Okay, so in this method, the idea is to eliminate one of the variables. Okay, so now look at the variables and decide for yourself which variable you want to eliminate. Now typically, the variable that you want to eliminate is the variable that has small coefficients, so that when you multiply by a number, your coefficient will not go so big. Okay, so in this case, the variable that has a smaller coefficient is 2. Okay, so then I will want to eliminate x. Okay, so let's eliminate x. So how can we do that? So the idea of elimination is we want to add the two equations. Okay, so we want to add the two equations. The idea is after adding, one of the variables should be eliminated. In other words, their sum is 0. Okay, so if you want to eliminate x, then we want our x here in the first equation to have a -2 coefficient. Okay, because if that's the case, if my x in the first equation has -2 as coefficient, then after adding, I will get 0. Okay, I will get 0. But how could I do that? Okay, so how can we achieve that? Okay, so we can achieve that if we multiply both sides of our equation by -2. Okay, and so if we did that, what will happen to our first equation is it becomes -2x minus 2y equals 0, and then my second equation stays the same. It's 2x minus 3y equals 5. Okay, and this is what I wanted. I wanted my variable x in the first equation to have a coefficient of -2, so that if I added these two equations, I will get exactly 0 for x. So that's where x is eliminated. Okay, so x has been eliminated. Okay, so -2y minus plus -3y, that gives me 5y, and 0 plus 5, that will give me 5, and then divide both sides by -5, so y equals -1. Okay, so I now have a value for y, and then all I need to do is substitute this value to any of my equations, but I will choose my first equation because it's much simpler. So that will be x plus, now instead of writing y, I will write -1 equals 0, and that will give me x equals +1. And so therefore my solution is 1, -1, which is what we got when we used the method of graphing and the method of substitution.